Many problems can arise during a mission to Mars. In addition, many issues must be secured to ensure a successful mission. While some points may not seem as prominent or important as others, adjusting every point is essential in making sure the mission works. Dust storms are one of these seemingly minor factors which could potentially interfere or even destroy a mission. The atmosphere on Mars is very thin, roughly 1% that of Earth's. Therefore, even the largest gusts of winds are only the fraction of the strength of those on Earth. It also means that only the smallest dust particles can be carried through the air. However, dust storms on Mars cover a much larger range than those on Earth. The lower gravity means that grains of dust and sand rise up to a meter in height, then go 3 to 10 feet downwind. Wind gusts up to 95 kilometers an hour can occur. Because Mars is a global desert, lots of dust exists which can be moved around by the winds. According to Jim Bell, Hellas Basin is the deepest pit in the solar system. This is where most dust storms originate. Because it is 6 kilometers deep and air travels based on its density caused by temperature, convection currents cause wind. The major concern of dust storms is their hindrance of generating solar power. Dust covers the solar panels, blocking the sunlight from reaching the solar panels. As energy cannot be generated as quickly, energy must be conserved until the dust storm has passed. Instead of using chemical processes to yield water, oxygen, and other necessary compounds, they will come mostly from storage. Processes that are not immediately required, such as recycling dirty water, will be delayed until full power is back. Lighting will be dimmed and EVAs will be limited, as well as rover operations. If an alternative power generator can be found, that could also be utilized. Nuclear power is an option for the future, but so far, the necessary technology does not exist. Storm season occurs in the summer, concentrating on the southern hemisphere. However, they can occur all over the planet. Dust absorbs sunlight, trapping heat. The sun is also more direct, causing hotter temperatures. It heats up the ground and changes the wind. The temperature regulating systems inside the spacecraft can make sure that the temperature remains life-sustainable. Research photos taken during this time must also use more infrared than visual wavelength media. If astronauts are not prepared for dust storms, they can cause trouble. However, through foresight and the decrease of the amount of energy used, astronauts can easily overcome this obstacle.